Hopefully that is what you can see. If someone can just confirm, we're good. So yeah, thank you for the introduction. I'm Pete from University of Bath. And just to clarify, I work at the BRE Centre for Innovative Construction Materials at the University of Bath. I'm not director of the BRE as such. And my task I was invited to talk about is Earth construction's potential to decarbonise construction. So I will attempt to answer that. So as many of us know, in fact probably all of us know, then traditional earth construction is and remains one of the most important and of course low carbon, low impact materials around the world. And we have a very long history of using the material. And the photograph here of the Great Mosque in Jenne, which was rebuilt in the early 20th century, is one example of a magnificent structure and also of a circular approach to construction whereby raw earth materials were used to reconstruct it. The comment that I make about diminishing global significance is partly in relation to some recent research. Often the extent of earth building around the world is sort of cited as 20, 25 or even more percentage of buildings and architecture around the world. Well, some recent research suggests that number is probably below 10%, but it's still an important, significant number. And that's probably in part because of the world population growth since that 25% number was first muted in the 1980s. So just to state some of the sort of global problem, and I'm sure many of you know this, but the built environment is the largest contributor to our global carbon emissions. The way we build buildings and wider environment and the way we use buildings contributes to, in many industrialized countries, around 40% of our total energy use. And similarly, depending on how we generate the electricity and other energy, around 36% of our CO2 or greenhouse gas emissions. And still we rely on a construction industry that's over-reliant on highly energy-intensive, cheap fossil fuel energy materials derived from non-renewable resources. And just to talk about the materials use, then the construction industry globally consumes around 40% of all raw materials that we excavate and grow and harvest from the earth, which is about 3 billion tons of materials a year. And the manufacture of materials that we use to build our infrastructure is around 11% of all greenhouse gas emissions. And some statistics there, just specific to this country where I'm speaking from, the UK, around 120 million tons of waste is produced as well. So not only does the construction industry use a great deal of resources, so produces a lot of waste in the process. And just in context, so some of you will have heard of this, no doubt, but the second most consumed material on the planet after water consumed by humans is concrete. We consume a huge amount of that material. And the production of cement that goes into concrete is a large contributor to CO2 emissions. And we talk more recently about needing to decarbonize our economy, and there are international agreements to decarbonize economies and get them to net zero carbon by 2050. And if we're going to do that, then in the construction industry as well as elsewhere, we need to improve our manufacturing and improve the functionality of our buildings as well, both new build and our great enormous stock of existing buildings. And so this revolves around improving energy efficiency and operation of buildings, using lower carbon materials, and also greater circularity in our processing and designing not for cradle to grave, but for cradle to cradle, with a view of how we use materials and products after the end of life of a building. And so what role can earth building materials play in this process? So I've been working on earth construction for around 30 years now, and over that period I've seen a variety of innovations in earth construction. And first of all is in terms of greater array of products, which manufactured products such as plaster products and building boards and even pre-maxed, pre-bagged rammed earth, as well as the figure there, a variety of unfired masonry units. And then in construction processes with earth, we've seen prefabricated wall panels, as the examples in the photographs show there, both from Martin Rauch, and also automated ramming processes, innovative formwork, and bagged earth, and different presses to make masonry blocks. And indeed, most recently, 3D printing used to produce earthen buildings. And very recently, there was a release about a building in northern Italy, which looks quite stunning. And of course, contentious issue at the bottom here is a recognition that for many people around the world, earth construction means stabilized earth construction. And we can talk about this till the cows come home and beyond. But there has been a lot of work done on looking at how to improve some aspects of the performance of earth building. And indeed, some of the natural processes we use in earth, whether it's compaction, for example, or mixing with natural materials such as cow dung, is a form of stabilization as well. And in recent years, we've seen a lot of research effort and innovation by industry and knowledge that we've generated to understand truly the performance of earth building and the benefits that it brings. I mean, to the extent, and I think one of the speakers earlier in the first session mentioned the amount of research that's been done on earth construction. And I probably can confidently say there are probably more people with PhDs in rammed earth construction in the UK than there are people who are actually making a living out of building with rammed earth. So we have a better understanding of hydrothermal performance of earth and construction, and the positive contributions that earth make to comfort and indoor air quality and indoor environmental quality of our buildings. A better understanding of the mechanical performance and structural design of earth buildings, a better understanding of the durability, and linking to that how we can best repair and conserve existing buildings. And this has fed into standardization, and as he mentioned, you know, of the New Zealand standards, and there are many countries, increasingly countries around the world, that now have standards for earthen buildings that have developed over the last 20 or so years. And a better understanding of the environmental impacts of earth building as well, and linking that through to how we can develop that into circularity, circular construction, which has also fed into training. And really, in terms of understanding what can earth do to improve the impacts that construction and buildings has upon climate change, has to be done through be informed. And one way, and the best way to inform the impact, is through something called, I'm sure you're familiar with, a life cycle assessment, and through understanding the various environmental impacts that processes and materials and products can have, then we need to use informed decision making. And we'll hear from the next speaker, I think, about environmental product declarations, EPDs, which is a particular take on life cycle assessment. And then sometimes, because of the impacts of a process or a product can be multifaceted, often in terms of looking at reducing greenhouse gas emissions, then often it can come down to the concept of just looking at embodied carbon dioxide equivalent, so the amount of carbon dioxide that is emitted to the atmosphere as the result of the construction and product manufacture through whatever the defined period is, through the cradle to gate, or cradle to grave, or cradle to cradle. And I'm again mentioning the aspect of circularity. And more increasingly, I think the construction industry more broadly is now increasingly aware of the positives of biogenic carbon, i.e. that plant-based materials through photosynthesis can take atmospheric carbon dioxide and turn it into cellulose, hemicellulose, and lignin, and it remains stored there within that plant material, whether that is trees or crops or other plant-based materials. And obviously, historically and in modern construction, earth and plant-based materials are often used together. So touching upon some research previously done, this is from 11 years ago now, but it was done by a student of mine, Claire, who working with Roland, looked at the life cycle assessment of rammed earth. And the diagram there just looks at the system boundaries, but basically looking at the impacts of raw material extraction, the transportation, the construction, the maintenance, and the end of life. So it wasn't particularly looking at it from a circularity point of view. But this image here, very quickly, shows, and it was done in the context of the Green Guide to Construction by BRE. So the scale on the y-axis is around eco points rather than around CO2 emissions. But the color guide here is what it's comparing is an unstabilized rammed earth wall with one that's got 1%, 2%, and 3% by mass cement stabilization, just as an interest in see what the impact of cement stabilization is. And we can see some of the largest impacts of rammed earth is around the mineral resource extraction. But as we start to add cement, then we start to see climate change impacts through CO2 emissions, as you expect to increase, but also waste disposal issues around circularity and reuse of materials coming in there. And then this is from a different piece of research done more recently and published. You can see the reference at the bottom, relating to work I've done with Professor Reddy and other colleagues at Bath, at the Indian Institute of Science. This is all on stabilized materials, because there's been a lot of work done in recent years trying to look at alkali activated stabilizers, or geopolymers as they're sometimes referred to. And really, our research has concluded that as an alternative to cement stabilization, the CO2 emissions from alkali activated or geopolymers have very little benefit. So direction of construction in general is towards trying to have net zero carbon solutions, both in the fabric and the operation. And we are seeing a greater use of renewable or bio-based materials, both timber and other slowly agricultural co-products. We've heard mention of straw bale earlier. And I think we're seeing the construction industry is moving towards greater prefabrication of construction. And of course, there's a pressing need to preserve and prolong the stock of our existing buildings and improve their performance. Also, I think there's an increasing recognition, certainly in Europe and North America, of in urban construction that we've seen in some recent years talk of building very large skyscrapers out of engineered timber, or some I've heard recently referred to as ply scrapers. I think there's a recognition that the most efficient way for urban areas is to probably develop in medium-rise construction. In terms, as you build larger and larger structures, then you need to start putting more and more material in to support the higher stories. So the optimum size of a building is in the sort of 6 to 12 story range to minimize that embodied carbon whilst maximizing the usable floor space. And the other thing in terms of construction is over the next 80 years or so, that the world will see the greatest population growth in Africa. I think for the rest of the world, the population growth, the figures I was looking at in preparation for this, is going to increase by around 2%, whereas the population growth in Africa is estimated to grow by over 200%, from something like 1.3 billion citizens up to over 4 billion citizens. And so if we are looking at where earth construction can make its greatest impact, then perhaps that's where it can indeed make a great contribution. So opportunities for earth building, I'm going to cognizant of the time. I think traditional earth building techniques such as cob, rammed earth and stuff still are relevant and have a place for sure. But in terms of wider construction market, I think there are many challenges in terms of their use as listed there. And so we need to find ways where we can best use earth incorporated with a construction industry that is increasingly moving towards prefabrication and use of timber construction. And as a personal viewpoint, then I think this is the opportunities lie in finishing materials, in plasters, in plaster boards, in insulation products, and using earth for thermal massing and hydrothermal regulation. And in terms of context of circular economy, I think there is a significant opportunity to use earth block masonry, including stabilized blocks, which would allow the materials to be reused at the end of construction. But also there will continue to be important projects using traditional and innovative techniques like 3D printing. But in terms of mass market, I feel that it lies with the higher points. Now this is a photograph of a demolished brick building, which has lumps of steel in as well. I've included it because the contrast there between using very high strength mortars and the potential for recycling as part of a circular approach here, Victorian 19th century masonry units, which were laid with a very low strength lime mortar. So using a similar approach with earth bricks and using earthen mortars, we can recycle the units as part of a circular solution. So to conclude, we need to recognize what earth materials can do best in the wider construction industry to have the greatest impact. We need to look at hybrid solutions which incorporate earth products, but not necessarily it's solely everything will be delivered in earth. And we need to see how best we can fit in with the trends towards prefabricated construction. And everything should be done and informed by a life cycle assessment to inform decision making if we are seeking to minimize our environmental impact. And finally, we do need greater circularity in our approaches. So that's my last slide. Thank you very much.